Here is another basic Newton's law problem. You just have to apply Newton's law in two particular directions. While applying Newton's law, you should always keep in mind that you always have to choose the right direction in which you have to apply the Newton's law. If you have chosen the right direction in which you have to apply the Newton's law, you will be always ahead. So, here in this question, on this block, which is of mass m1, we can take two components of the gravitational force acting on the object, that is m1g sin theta and m1g cos theta, and there's another force tension here, and the normal reaction due to the wedge. For the other block, m2, it experiences m2g here and the same tension there. This is because in a particular string, if the string is massless and it passes over a massless pulley, then the tension in the whole string is always the same. Remember this thing, if either the string is having mass or the pulley is having mass, then the tension in the whole string will not be same. Here in this case, the pulley is massless and the string is massless, therefore the tension in the whole string is same. Now the acceleration of this block is a upwards. The acceleration of this block will also be a upwards, a downwards. This can be found out by, let the length of this string be L1 and the length of this part of the string be L2. We know that L1 plus L2 is equal to constant. We differentiate this once to get L1 dash plus L2 dash barabar 0. L1 double dash plus L2 double dash equals to 0 again. Now L1 double dash is the acceleration with which this length of the string changes. That is equal to, let this be A1, this be A2. This is equal to minus A1 because this is going and reducing the length by A1. This pulley is fixed, due to which there will be no other factor here. This is minus A1, this is plus A2. By similar logic, this is going below by A2. So minus A1 plus A2 equals 0. Therefore, we get A1 is equal to A2. This is known as string constraints. In the same form, string constraint can be applied for any other string. If there are multiple strings in a particular question, you apply the same string constraint for each of the strings to get the relation between all the accelerations. Now we get a relation between A1 and A2. They are both equal. Let's call them A. So applying Newton's law on M1 along the incline to get P minus m1g sin theta equals m1a. Similarly, when we apply Newton's law on this object in vertical direction, we get m2g minus t is equal to m2a. Now we need to find out acceleration first and then the tension. We add these two equations to get m2g minus m1g sin theta is equals m1 plus m2 into a. So we find out the acceleration as m2g minus m1g sin theta upon m1 plus m2. So we now know the acceleration of both the blocks. Now to find the tension, we simply put in this acceleration in the above equation to get m2g minus t is equal to m2a. Tension is equal to m2g minus m2a. So we get the tension as m2g minus m2 into m2g minus m1g sin theta upon m1 plus m2. So this is the final answer for the tension in the string, and this is the final answer for the acceleration of the two blocks.